Welcome back. We have learnt about transaction. There is another buzzword that will be used again and again in blockchain, that is hashing. Let us now see how hashing works in blockchain. Before getting into the use of hashing in blockchain, we'll see what hashing is. Hashing is a process in which you give an input to a hash function f of x. You will get one output. But for any input that you give of arbitrary length or for variable length, you will get a fixed length y always. That is the beauty of hash function. So let us see with an example. Let us take a text. Hello, how are you? This is a text that we are going to pass to the hashing function. When you pass it to the hashing function, you get a hexadecimal value, which is nothing but a hash value. When you just give a different text, which is hello, same hashing function, you get a different value. But when you look at the length of the hash value that is generated or the output that is generated, it is same. So whatever the length of the input is, the output would be same, or the length of the output would be constant. So for variable length input fields, we will get fixed length hash value always. Even a small change in the input, it will make a drastic difference in the output. Let us see it. Hello, how are you is a text again. We get the same hash value. But if you change this h, that is the capital H, or this h to a lowercase alphabet, even that small change will make a drastic change in the hash value. Let us see that. So here this h is modified to a small h. Could you see the difference? The entire hash value is changed. Let us see this with an example. This is a tool. Whatever that input that you type, hello, how are you, or just how are you, you get a hash value. You just change even a single character, that is, I'm just adding a question mark, you could observe the hash value is completely changed. So even a small change in the input will make a drastic difference in the output. And always this value that you get is deterministic, which means that how many hour time you type this, the same hash value will be produced. So let us just check it out. For how, you just note down like 1325707. This is the starting set of characters for the hash value. So this is a hash value. But if I type how are you, the hash value is completely different. I'm typing how are you. Now you got the same hash value that you have received earlier. If I just add a question mark, you get again the same hash value. So whatever the value that you give, depending upon the value, you will get the same output always. And even the length of the input change, even the length of the input change, you could observe that the hash value is changing, but the final resultant length of the hash is same. As we have observed, even a small change in the input will be giving you a different hash when you pass that input to a hash function. So what are the properties of hash function? One is, it is one way. The mathematical function will allow you to convert any text into a hash value, but not on the reverse way. So you cannot give a hash value and you can never ever get back the input that you have passed on. So it is completely one way. And the next one is deterministic. Deterministic defines that the hash function will be giving you the same hash value out all the time or every time you give a particular input. And it is not just a random value, and it is not just a randomly generated hash. So it is completely deterministic, which means that the same hash will be generated each time for the same input. But if you vary the input, even a small change in the input will lead to a drastic change in the output, not on the length, but on the characters. This property is what called as an avalanche effect. So you will have an avalanche effect, which is small change in the input will lead to a drastic change in the output. So these three are the properties of a hash function. Okay, what are the hashing algorithms that we have? There are many algorithms that are existing. One famous algorithm that we have used in the demonstration is MD5 algorithm. MD stands for message digest. Algorithm that is used very popularly in Bitcoin is SHA, that is secure hash algorithm. Especially, to be very specific, it is SHA-256. This 256 indicates the length of the output. So you will have 256-bit hash that will be generated as a output. And when it is SHA-512, then 512-bit hash will be generated as a output. This secure hash algorithm was developed by National Security Agency. As I told you, SHA-256 is popularly used by Bitcoin, and there is another network or a blockchain network, Ethereum, which uses Keccak-256. So Keccak-256 is the algorithm that Ethereum is using. Okay, we've learned about hashing. So hashing is you give input to a function and that function will be generating a fixed length hash value which will be deterministic always, and even a small change in the input will lead to a drastic change in the output. So use of this hash function in blockchain. Firstly, the blocks are linked together using hash. That is a chain of blocks. You could see here the blocks are interlinked You could see here the blocks are interlinked with each other through hash. This is a block number 2. The previous field of block number 2 will have the hash value of block number 1. So you could see here it is 00001578, and here also it is 00001578. So each block is linked with the entire blockchain only through the previous hash. So when a new block is getting added, the last block's hash value will be stored in the previous of the new block, and now the new block will be linked with the earlier block, and hence it will be linked with the entire blockchain. The hash functions are used to link the blocks together into a chain. Another one is Merkle tree. So we'll be learning about what Merkle tree is in the forthcoming video. But before that, already we have seen Merkle tree contains the hash of all the transactions, and Merkle tree root will be stored in the blockchain header. And the next one is proof of work consensus. In proof of work consensus also hashing is used. We'll be learning about how that is used. And the other one is in the digital signature. So digital signature is also part of the transaction in the blockchain. Whenever a transaction happens, the owner of the transaction or the person who initiated the transaction will be authenticating the transaction through the digital signature. In the further videos, we'll be learning about, in the future videos, we'll be learning about how Merkle tree works, how Merkle tree is generated, and also how proof of consensus or proof of work consensus works, and then the digital signatures.